welcome to the April HAS Novice meeting. My name is Chris Morisette. I'm the Novice Chair for HAS, and I'm glad y'all were able to dial in tonight to the Zoom meeting. What we're going to be talking about tonight is the spring sky. So galaxy season is here. We're going to be talking about navigating the spring sky. And springtime is a great time of year. Before we get too far into the presentation, if y'all would please mute your microphones. And if you have any questions, go ahead and put them in the chat. And then when I finish, I'll go back to the chat and go through the questions. So I appreciate that. So our topics for tonight, we will have, so this is our quarterly Navigating the Sky presentation. I do these winter, spring, summer, and fall. And again, for the novice, this is just a way to get you acquainted with the basics in terms of navigating the night sky. And I like to cover a little bit about navigating, some of the basics about the celestial sphere and the coordinates on the celestial sphere, things like that. And then we'll get into our signpost discussion. In this case, it's going to be the Big Dipper. And then we'll go through and we'll tour kind of a select handful of spring objects that are out there for the taking. I'll wrap up the discussion with a little bit of information about Novice Labs. Those are something that I wanted to do more of here. I've been trying to get one launched here recently, but I haven't had too much luck with the weather. But a little bit more information on that to kind of wrap up. Okay, so navigating the night sky. Applications on your phone and go-to mounts are great, but you really would like to be able to know the night sky, in its manual form, so to speak. You'd like to be able to go out there without the aid of any electronics and find your way around. And that's the goal. I will say this, I'm putting together a presentation for the May Novice meeting that will be about phone apps. It won't be so much about which one's the best and that kind of thing. It's going to be more of a demonstration using Stellarium and to kind of show you what you can do with the power of a phone app is, because while we encourage you to go out there and do things and learn the night sky on your own. The applications do have a place in our toolbox, and I wanted to go through and spend some time doing that. So just kind of a heads up on that. So you really, in our quest to learn and understand the night sky, you really want to focus in on and learn the constellations first. There's 88 of them. I'll be honest with you, I don't know all 88. I know the ones that are important in the things that I do in the night sky, in particular astrophotography. There are certain constellations like Cygnus where I find a lot of cool objects to photograph, so I know that one well. Orion, of course, is another one. But all 88 of them, no, I wouldn't know those. And I would say when you're first starting out, I would focus on the big hitters, like Orion, the Big Dipper. Although it's not a constellation per se, the Summer Triangle, which is an asterism, and the Teapot, which is another asterism in Sagittarius. Focus your attention on those. Cassiopeia is another one that we use a lot. And then as your interest develops, you're going to kind of dig into it more and more as you study star maps and things like that. So don't feel overwhelmed. Start out with the basics. And then even before that, learning the brightest stars is a good idea as well. We have very light polluted skies here in Houston, in our suburbs, and it's not always possible to see constellations in their fullest extent. So what I found is, as a good way to at least get me in the right spot, is to learn some of the brightest stars that are out there. And this picture that you see in front of you are the 24 brightest stars, I think, in the heavens. I've grayed out the stars that are really more of a southern hemisphere star and left unshaded those that we can utilize. So in our discussion tonight, Spica, which you see down here, which is a very bright star, and Arcturus, which you see up here, which is very bright. So those will play a pretty prominent role in finding our, navigating our way around the spring sky. So again, just to even make it simpler, take a look at this collection of stars and leverage that as best you can to, get yourself into the right neighborhood of a constellation. Another good resource for learning constellations are a couple of books by a children's author by the name of H.A. Rey. He was famous for Curious George, and he wrote a couple of books called The Stars and Find the Constellations that are really helpful. Although he is a children's author, we can still, as adults, take advantage of his work to help us get going if we're just starting out in astronomy. One thing that H.A. Rey did with respect to finding, the constellations is he reconfigured the lines between the various stars that make up a constellation. So the stars that are out there that make up a constellation, he didn't change that at all. Instead, what he did is he rearranged the lines so that the figure that you see uh, more closely reflected the mythological symbol for that constellation. So to give you a couple of examples here, down here you see the constellation of Virgo, and here is an older or maybe a more traditional connection of the stars within Virgo. And what H.A. Rey did is he made those into these connections right here. Again, the stars didn't change, it's just the connection between the stars. And what you see in H.A. Rey's picture is a more definable person, which is Virgo, the Virgin, who is sitting or reclining, and that's what you're seeing more clearly here. Another good example here is Pegasus. So Pegasus, as we know from Greek mythology, is the winged horse. Here it's kind of tough to tell that is the mythological symbol, whereas if you just reconnect the existing star pattern in a different way, you see something that resembles more of a winged horse. So it's a great way to learn, and it's a simple way to learn, and I highly recommend it to you. Now, as you get more involved in astronomy and you get more involved in going out and finding deep sky objects, particularly if you're finding deep sky objects using visual astronomy, you're really going to want to invest in a good star chart or star reference manual. You're going to have to get down into the details and the detailed star patterns that are required in order to find some of these objects that are out there. Okay, so there are a number of good ones out there. I had one called Left Turn at Orion that was really great. Here, the Pocket Sky Atlas by Sky and Telescope is another really good one. And again, these are references that I think you want to invest in as you get more into the hobby. You get more involved in finding deep sky objects like open star clusters and things like that. This is where these can really come in and help you out. There is one one reference that I have fallen in love with, and unfortunately, this thing has gone out of print. But it was authored by Orion. It's called the Deep Map 600, And here you had what I consider to be kind of a beginner star reference that folded up into the size of a gas station map. So it was very handy. It had a nice waterproof covering on it, so it was suitable to take out into the field. On the front, you had the celestial sphere kind of laid out as a rectangle, like you would see the wall map of the Earth. And then if you flip it over on its back, you'll see a kind of a little database of information about the various deep sky objects that are identified on the front. You really can't make them out on this slide that I've got here. But if you look closely, if you ever get a copy of this, and you look closely, you'll see many Messier objects, new general catalog objects, things like that. And again, you can flip this thing over on its back and you can get more information about, its size in arc minutes and arc seconds, its brightness or its magnitude, what constellation it is, what kind of an object it is. So it was really a handy reference. I thought ahead and I picked up about 5 or 6 copies and I use them for a beginner's class that I teach, and I'm glad I did. So that I can use those, but unfortunately they're out of print. Hopefully, if by some miracle, if it comes back into print, I'll let everybody know. That said, I have been looking for some alternatives, and here is the best alternative that I found so far. National Geographic has what they call a Stargazer series, and here you can buy these various maps a la carte or buy the 4 as a package. If you're going to go buy these, I would recommend getting them as a package because the cost per map is lower. And for Houston, you're going to need both the north and the southern hemisphere. Unlike the deep map, which has a really good view of what we would see here in Houston, the northern hemisphere map shows you the top half of the celestial sphere. So everything above the celestial equator is shown here in the northern sky. And that's fine, but we can see a lot of things that are below the celestial equator here in Houston. So you're going to need both maps, and that's one drawback that you have with these maps. Another drawback is that it's not as easy to read as the deep map was, but again, you can, with a study, you can figure it out. It does have not as many, but many of the common Messier objects on here, deep sky objects that are popular to go view. And one thing it does have that the deep map does not, it has dotted boundaries around the constellations, which is very helpful. And that is one thing you don't have with the deep map. You really can't tell. It's kind of tough to tell where a constellation ends and another one starts. Here it's more defined. So that is one advantage. If you flip this on its back, there are, I would call them, for lack of a better term, kind of a planisphere for each season. And here they do show more than just what's above the celestial equator. So that's nice. And the other thing too, if we zoom in on one of these, here's a zoomed in picture, and I'll go zoom in even more. One neat thing about these maps is they have the signpost that I use to teach, to go through these quarterly sessions with. I think the signposts personally are very handy, useful ways to teach navigating around the night sky. In addition to the signposts that I use, they have additional ones. Here you see the winter hexagon, and so these maps do help promote and help visualize and help document these signposts. So that's another positive feature. I think all 4 maps together cost about $30 from Amazon, and each by themselves is about $10. So you save a little bit of money there. But until I find a better one, this is really the one I would recommend. Another great tool is a planisphere. These are nice to be able to go out and dial up the night sky depending on the time of the year, the day of the month, etc. Um, these planispheres are designed for short range of latitude. So Houston's very close to 30 degrees. So in this particular case, this one would work. The northern part of the U.S. is close to 40 degrees. So again, this is another tool that you can use. Again, I bought one. I used it for a little bit, and I thought it was fun. It was useful, but at the end of the day, it was a little bit clumsy for me. But I know a lot of people use them and love them, and I encourage you to take a look at these as well. Talk to people that use them all the time, and get some other opinions about them. Another great resource is the skymaps.com website. Here you have a free monthly download that you can make of the northern hemisphere. They also have ones for the southern hemisphere and for the equator, countries that are located close to the equator. So it's a great tool. I'm showing you just one page here of, I think, about 2 or 3 pages. So there's more information here than what I'm showing. But this is how you would use this map. This particular map is going to be close to what you see in the sky when it's early in the when it's early in April. That'll be about 10 o'clock at night. As the month progresses, when you get into the latter part of April, this will be more representative of what you see earlier in the evening, say 9 o'clock. And again, the way you would use this map, and if you just pardon me 1 second, I'm going to grab a quick drink. Thank you. If you the way you use this is you take this particular sheet of paper, you go out on your driveway, you face south, the southern, south, the direction south, and then you have the word south, which you see down here on the map, pointing down towards the ground. And then when you do that, and then you look up from the map up into the sky, you will see the various representation of stars and asterisms and things of that nature. So for example, you'll see Virgo, Leo. Here we have Cancer, Gemini, and then even Orion is still over here, although it's fading off into the distance. Now you'll notice that I have a big red circle around one of the objects here called M44, which is the Beehive Open Star Cluster. And you'll notice that when I'm looking at the Beehive Star Cluster here in Houston, I'm facing south. Okay, so remember that. We're going to come back to that in a little bit, kind of have some information that's kind of fun to play around with there. So Beehive Cluster M44, I would be looking south here in Houston, Texas. Now, if I want to see what's in the northern sky, I would simply rotate my body 180 degrees so that I'm pointing north, and then I would take the map and I would turn it upside down so that the word north was actually down at the bottom of the page, pointing towards my driveway. And then here's what you would see up in the night sky. So for example, you would see Polaris, the Big Dipper, which we'll be talking about a lot here during the course of the presentation, Pegasus, and other constellations that are out there in the night sky. That's a great resource. It's free, and highly encourage you folks to make use of this. So those are some of the references that we can use. Let's talk a little bit about the model itself. So when we talk about the celestial sphere, we're really talking about this imaginary sphere that envelops the Earth, and it mirrors our own equator and our own north and south pole. So the celestial equator will be the same as the Earth's equator, and the North Pole will be the celestial North Pole will be the same as our North Pole, which is where Polaris, the North Star, resides, and ditto for the South Pole. There are two really important features, or what I would call coordinates that define and anchor objects in the night on the celestial sphere, and that's right ascension, which is analogous to longitude on a terrestrial map, and declination, which is analogous to latitude. And so those two coordinates you'll see a lot, and what they're really doing is they're pointing to a spot on the celestial sphere that you can find a star, you can find a galaxy, an open star cluster, a nebula, what have you. Okay. The other thing that's of note here is the this dotted line here called the ecliptic. And the ecliptic is where we're going to find the sun, the moon, and the planets. Here is another view of the ecliptic, and the top part of my thing is blotted out, but I believe it's this red line here, because here you have Virgo, and I think going along here you have Gemini, so on and so forth. So the ecliptic is where you find the the constellations that have the names of the zodiac. So things like, and did I say that right? So zodiac signs. You'll notice that there are constellations that share zodiac signs. So, for example, Gemini, Virgo, Leo, Taurus. Those constellations share zodiac signs, and they reside on the ecliptic. There was a 13th one here called Ophiuchus, but astrologers are only worried about 12 months, and that one got cut off the list. So, just a little bit more about our celestial sphere. And again, well, it's not really important, but my point here is that the zodiac, the constellations that have a zodiac, that share a zodiac name from astrology, reside on the ecliptic. A little bit about latitude. So the apparent motion of the stars is going to be dependent on our latitude. So, for example, if I'm at the North Pole, the North Star will be directly above my head at the zenith, and stars will appear to rotate around my head, or around my body, if you will, depending on how high up on the celestial sphere they reside. As I move farther south, that changes. So Polaris is at 90 degrees when I'm at the North Pole, but as I move down towards Houston, it will actually be 30 degrees above the horizon. So that's how Polaris works. Once you get down below the equator, Polaris disappears from the night sky, and when you're in the southern hemisphere, Polaris is not visible at all, and you can't really use it as a navigational tool. So that's how we can find Polaris. So we're lucky to have it, and that is where you would find it. You would find it basically whatever latitude you're at in the northern hemisphere. That would be the degrees above the horizon where you would find Polaris. And then going further and talking more about Polaris, Polaris is well, it's actually the center of the celestial North Pole, and the stars that are in the immediate vicinity of Polaris are called circumpolar stars. So any star that's within, in our case, within 30 degrees of Polaris, here if we're in Houston, they will never go down below the horizon. They will always be up in the sky. Now, obviously, when the sun comes up during the course of the day, they disappear because, by virtue of the sunlight. But they're still up there in the sky. Anything that's farther out than 30 degrees will be circumpolar as well, but it will set below the horizon for a certain period of time. Here's a great example of what we're talking about here. So this is a picture from one of our HAS members, and I believe this is out in West Texas. And you'll notice here that the center of the circle shows you is where Polaris would reside, and then these stars that you see, these star trails that are shown in the picture are actually the rotation of the various circumpolar stars. And anything that's within 30 degrees of Polaris will stay up above the night sky, or up above the horizon, rather. So it's a great way to think about it, and kind of cool to include in the package. So for example, this star right here will be circumpolar. It will always be above the horizon, whereas we get out here, these two stars here will go down below the horizon. And again, I'm pointing this out because again, this is this kind of brings a little bit more information about the function of the celestial sphere and how we would relate to that in Houston. So let's talk about a little bit more, or continue our talk about Polaris. You've got to be able to find Polaris, and an easy way to do that is to go off of the pointers that are on the end of the cup of the Big Dipper. And if you draw a line from those two stars out, you'll find it. The star Polaris is actually at the end of the Little Dipper handle. It is a star that I can certainly see from my home up here in Kingwood. I don't know how that looks down closer to downtown, but I think out in the suburbs, you have the ability to see Polaris. But in my case, not much else of the Little Dipper. So you can, the Big Dipper is very apparent and bright. I can easily make that out where I live. And then once I do that, I can find Polaris from there. And so that's how you're going to be able to find Polaris when you're out trying to find that in the night sky. And again, here's another example of how the Alaska state flag does it. And again, it demonstrates the same thing. You can use the Big Dipper as a way to navigate and find Polaris. This picture right here is a good one. It again shows that the Big Dipper does circle around Polaris. And you can see here that during what I would call kind of prime time viewing during each season of the year, and I'm talking just in rough terms between, say, call it 9 and 11 at night, you can kind of see where the position of the Big Dipper is. So in the winter and the autumn, the Big Dipper is very close to the horizon. And as a result, it's not a very useful tool to use to find your way around the night sky. Excuse me, just a second. When we get into spring and summer, the Big Dipper is high up in the sky, and as a result, it is a very handy and useful signpost to help us navigate around the night sky. So that's why we focus in on it during spring and summer. Couple of more things about the North Star, and then we'll focus in on the Big Dipper a little bit more. But it's by luck that we have a North Star, and Polaris will not always be the North Star due to a phenomena called precession. And you'll see this thing up here called a precessional circle, and that is a circle that is made by the axis, in this case, of a gyroscope. So you can see it's just like a spinning top that a child would have, or a gyroscope. It's going to spin, but there's going to be a tilt to it, and as a result, you're going to get this precessional circle. Okay, and that's what you're seeing here. So what does that mean? What that means is that Polaris, while we have it really close to our, well, essentially on the celestial North Pole, it won't always be there. As a matter of fact, a precessional circle it makes one rotation about once every 26,000 years. So in about 13,000 years, we'll actually be looking at and pointing to a new North Star, and that new North Star will be Vega. So you might ask yourself, well, is this really relevant? I mean, obviously we're not going to be, we're not going to be here anymore. That's an awfully long time. As a matter of fact, civilization going back to ancient Egypt is only maybe what 5,000 years old, 6,000 years old, something in that neighborhood. Well, in fact, it was a factor when in ancient Egypt, because at that point in time, which was roughly 5,000 years ago, you were at a different spot on the precessional circle. So if this whole thing is 26,000 years, you can imagine a good chunk of this is going to represent about 5,000 years. And what they discovered is that the pyramids, when they studied the hieroglyphics of the age, the pyramids are actually built in a manner so that parts of the pyramid face the North Star, or their North Star, which is actually a different star than Polaris today. And again, it's because 5,000 years ago that we were in a different spot on the precessional circle. So I thought that was kind of neat. Thought I'd just mention that and bring that out as a point of interest in with respect to the precessional circle. There's also another phenomena called nutation, and that is this wiggling motion that you see here. So while a precessional circle is made, there's also a little bit of a wobble or a wiggle in that line, and that's more frequent than our rotation around the precessional circle. So as a result, star maps and charts need to be updated. Back in the day when it was all paper, that was a big undertaking. Nowadays, with things like planetarium apps and everything being so electronic, it's not as much of a big deal as it used to be. So that's just a little bit more about our North Star, precession, and nutation. One last thing before we dig into the signpost of the Big Dipper is that you can use your hand to measure distances in the night sky. Very simple. The width of my pinky is going to represent 1 degree of distance. 3 fingers will represent 5. A fist will represent 10 degrees, from side to side. Hook'em horns will get you 15 degrees. And then the last one, pinky to thumb, will be 25 degrees. Again, if you don't have sophisticated tools or a go-to mount with you, you can use your hand as a handy way, pardon the pun, to find distances around the night sky. Okay, finally we get to the Big Dipper. So one more sip, excuse me. Okay, so now we'll focus in on the Big Dipper as our signpost. And if you remember from January's talk, we talked about Orion being the big signpost for the wintertime. And we could use the various star patterns to draw lines and find our way around the night sky. But we don't have that luxury anymore because we've moved to this position, if you will, during, again, that prime time viewing, which, again, I'm just, throwing out a rough period of time, so that early evening, mid-evening period of time. We've moved positions by virtue of our orbit around the sun. So we're now in a new position with respect to the night sky, and that's what I've tried to denote with this green box here. So Orion and Cassiopeia, which we use during the winter, are off to the right. They're still available to, we can still see these. We'll see these in early spring, but by mid or late May, these things will be down below the horizon when it gets night out. So they won't be useful to us anymore as a signpost. Here we're going to have to use the Big Dipper, and we're going to couple that with the stars Arcturus and Spica in order to get find our way around the night sky. And then here's the Big Dipper up close, and here's more precisely how we can use this to find our way around. So we talked a little bit earlier about using these 2 stars here and here to draw a line out to Polaris, which we've talked about earlier. You can also use the top 2 stars of the cup to go out here to Capella, which is located in more of a winter constellation. Here we can go from this point here on the cup down to the bottom point of the cup, and we can get down to Castor, which puts us in Gemini. Again, this is more of a winter constellation, but it's still there's still some useful things that we can go out and see and look at in Gemini. Here we can really get into the meat of the action for spring, though. We can use these internal stars here and here and draw a straight line and get down to Regulus, another bright star that was on that list earlier. And if we get down to Regulus, then we can find ourselves in the constellation of Leo, and Leo has all kinds of cool things to look at, which we'll talk about here in a little bit. So that is a great way to get down into the thick of things for our springtime viewing. Another way to get down into the thick of things for our springtime viewing is to follow the stars on the handle of the Big Dipper. And if we follow that, we can do what we can arc to Arcturus. And in this picture shows it a little bit clearer here, but I can follow these stars and I can arc down to Arcturus. Arcturus is a reddish star. And when I was first doing this, I thought, well, how in the heck am I going to find this thing? Is it going to work? And with a little practice, it was a piece of cake, especially if you're out in the suburbs where there is some light pollution, because Arcturus is one of the few distinct stars that you can see, and you can clearly make this out. So what we do is we arc to Arcturus, and then once we get to Arcturus, we can speed on to Spica. And Spica, again, is another bright star. Arcturus was reddish in hue. Spica is more white or bluish in hue. And once we get to Spica, we're down in the constellation of Virgo. And Virgo is, you know, it's the hot spot for summer or for springtime viewing, because that's where the Virgo's cluster of galaxies are. There's a lot of cool objects around Virgo. So, you know, we've hit pay dirt. We've really we'll be able to get to a spot that'll yield all kinds of neat things to look at. And even in Arcturus, which is in a constellation called Bootes, there are some cool things around there as well. But that's how we'll use these the Big Dipper in order to find our way down to these areas of the night sky that we want to look at. Okay, so with that, we'll start our spring sky tour, and I'll, as we go through these, hopefully I'll point out in more detail how we can, you know, find the various objects here. And I've got my cheat sheet in front of me here, so if you see me looking down, it's because I'm using my cheat sheet. Okay, one thing before we get into that, though, is why is it galaxy season? When I first heard springtime referred to as galaxy season, that was a little odd to me. And here's a short explanation on that. In this point in our orbit around the sun, we are actually up at this position right here. This would be spring equinox, which would have been, you know, March 21st. And you'll see at this point in our orbit around the sun, we're in a position where we're looking through a minimal amount of the galactic disk of the Milky Way, and we're looking way out into deep space. So in the summer, we're looking back in towards the core of the Milky Way, and you know, we're not going to really see much of any galaxies that period of time, because we're in the thick of the galactic disk of the Milky Way. Here, we're out on the fringes, and we have a kind of a perch to kind of look out into deep space. So that's one reason. And then the other reason is that in addition to being able to look out into deep space, we're looking at an area of the sky that is just rich in galaxies. In particular, this period, or this section of real estate between Leo and Virgo is just chock full of galaxies. And again, we'll talk a little bit more, show you a little bit more about that here in a minute. Okay, so that's a little bit why they call it galaxy season. Let's start our tour, and our first stop is going to be an easy one. I always like to start with an easy one so I can get a win under my belt and then feel confident about going out and finding other objects. So the first one we're looking at here is called Alcor and Mizar. It's the center star of the Milky or the Big Dipper handle, um, it, in my when I look at it, it looks like one star. But my eyesight's not what it used to be. I think with younger fellas and gals can, uh, with good eyesight, can actually make out the two stars um, naked eye, but I can't. However, when I get my binoculars out, it's clear as day, clear as night, that there are indeed two stars there in that middle section of the handle. And so this is a double star. It's about 82 light years away from Earth. And again, it's in the constellation of Ursa Major. Remember, the Big Dipper is an asterism, which is really a pattern of stars. It's kind of a subset of a constellation. So the Big Dipper is actually a subset of Ursa Major. But this is where we would find Alcor and Mizar in the middle handle of the Big Dipper. Now, the cool thing about the Big Dipper, it's got some neat things that are really close by. So if we go off of the end star on the handle, Alcade, and we go about 3.5 degrees, let's call it maybe 5 o'clock from Alcade, we can get down to a galaxy called M51. This galaxy is shown right here, and it is about 28 million light years away from Earth, 112,000 light years in size, so slightly larger than our own Milky Way. And it's actually in a different constellation than Ursa Major. It's kind of right over the border, if you will. Now, this is a really great example of what galaxies do. And what galaxies do is they like to collide and interact with each other. And if you remember, Bill Spizzirri gave us a talk on the Milky Way for the Novice presentation back in February. And it was one of the things that Bill impressed upon us is that, galaxies are interactive. They will interfere with each other, collide with each other, gravitationally affect each other. We will run into Andromeda at some point in time out in the way distant future, but that's our destiny, that's our fate, and that's what galaxies do. In this particular case, you can see that the larger galaxy, M51, and its companion galaxy, which is NGC 5195, are definitely interacting with one another. This one appears to be pulling material off of it into its own, into the body of its own, um, uh, into the body of M51. So when I first started out in astronomy and I first heard this, I thought, wow, what an unusual story. And the more I looked into this, the more I heard about things like this, the more common it is. So, we live in a living, breathing universe, and galaxies are huge structures, but they definitely play an active role. They're not just static islands of stars out in the sky. They're moving and colliding and doing all kinds of neat things. So that's M51, very dramatic example of galaxy interaction. If we go up above the handle, and let's say we go about 5 degrees above the Big Dipper handle here, we can get to another galaxy, M101. And here, excuse me, let me grab a quick drink here. Pardon me for a second. And here is an exquisite image that Jeff Lepp let me use for the presentation. This is M51 or M101, excuse me. It's the Pinwheel Galaxy. And this is about 23 million light years away from Earth. It's about 162,000 light years in size. So our own Milky Way being 100,000, it's about 1.5 times the size of our own Milky Way. Now, the thing that you want to look at in this picture, which is really cool, are these red, really large red areas of star formation. I believe they're H alpha star forming regions, but they're huge. I mean, they're huge to the point where, we can see them here on Earth. And I thought that was really cool thing about this this image that Jeff took. In addition, this galaxies produce 3 supernova during the 20th century. So a lot of cool things, a lot of activity, a lot of action going on with M101. And again, it's right up near the handle of the Big Dipper, so you don't have to travel far in order to get to it. Okay, let's talk about a couple of my favorite galaxies, M81 and M82, and they are Bode's galaxies. That's kind of their title. And in order to get there, you want to go off of the end of the Big Dipper cup about 14 degrees that away. And when you do that, you will get over to these two galaxies that are having an effect on a profound effect on each other. So M81 is the larger galaxy that you see here on the right. It's about 74,000 light years in size. M82 is on the left. It's about 37 light years in size. Both of these galaxies are about 12 million light years away from Earth. And the cool thing about these two galaxies is there are visible effects that you can see in M82 from M81. And in particular, I just want to draw your attention to this red crease that you see in here in M82. That's actually an area called a starburst region, and you get what you're seeing here is an accelerated production of stars. And the theory goes is that the gravitational effects from M81 are compressing the gases in M82 and creating this accelerated star formation. So again, another example of where galaxies are interacting with each other. They don't necessarily have to collide or touch each other, but just due to the massive gravitational effects of each galaxy, they can have an effect on each other. And so I think that's a really cool story. And it is, again, a couple of really cool galaxies as well. And even M82 is having a warping effect on M81. You really can't make it out from this picture here, but it's, again, pretty cool stuff. So that's M81 and M82. Now what we're going to do is take a look at something other than a galaxy, although we'll come back to more galaxies. We're going to go down to fairly close to Arcturus. So remember, we can arc to Arcturus. You can't see it in this picture, but the Big Dipper handle is up here. And if we follow that down here, we'll get to Arcturus. And if we go about 10 degrees at, say, 2 o'clock from Arcturus, we can get over to a globular cluster called M3. So here is M3. It's a globular star cluster. This globular star cluster is about 32,000 light years away from Earth. So it's in the Milky Way. And it's about 11 light years in size. And this cluster is actually located just right over the border in Canes Venatici. So here's Arcturus and Bootes, and then you go right over the border here, you're on M3. Anyway, it is you're looking at about 500,000 stars here that are gravitationally bound to each other. And globular clusters are really beautiful objects, kind of fascinating objects, they're very old objects. And this is a great example of one that we can go out and view, find and view during our springtime activities. Let's see. One thing that's interesting about globular clusters is that they reside in the halo of the Milky Way. So they're not down in the dust in the galactic plane with us. They're actually out in the halo. And so they are gravitationally bound to the Milky Way, but they'll actually orbit in and around they orbit and will eventually at some point in their orbital path go through the disk of the Milky Way, but by and large, here's where you're going to find them, out in this halo. So that is M3. Moving along, so now here's where we're getting into the thick of the action for galaxy season. So you see here Spica, which is the main bright star of Virgo. And up here in this part of Virgo and you can't see it in this picture, but Leo actually resides out here as well. But between Virgo and Leo, you get this the Virgo supercluster. And here we're going to take a look at this collection of galaxy called Markarian's Chain, which I've circled up here with a yellow oval. And then down here we'll look at the Sombrero Galaxy. So let's look at Markarian's Chain. This is a series of galaxies here, 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 here. I think there's about 10 or 11 galaxies that all appear in one field of view. And this is a really great depiction of the Virgo supercluster to kind of give you an idea of how populated it is with galaxies out there. So this is a subject that I have on my list to photograph, and hope to do so if I get some good weather this spring. But that's a wonderful picture, and it lends itself to pretty wide field of view equipment, which is what I have. So that's really neat. So this is the Markarian's Chain. And then the next galaxy that I showed you here, we'll just go back up here quickly. It's down here at about right at 3 o'clock from Spica, and it's about 7 degrees at 3 o'clock from Spica is the Sombrero Galaxy. And this is a beautiful edge-on galaxy. You've got that distinctive dust lane around it. You've got the glow of the galactic nucleus. And this is a really great image from Brad Burgess that he allowed me to share with y'all. And so this is another wonderful object to go out and view. Edge-on view of a galaxy. Okay, so now we're going to go to the Beehive cluster, M44, which is right here in Cancer. And we can get to M44 by going and finding Regulus. Remember, we could find Regulus from the Big Dipper. And I think this is Regulus right here. And if I go from Regulus out about 18 degrees at about 2 o'clock, I can get over here into Cancer and to M44. So M44 is the Beehive Open Star Cluster. It is about 610 light years away from Earth, and it has about 200 to 350 stars in it. So it's a wonderful star cluster to go out and try to view. I find star clusters pretty challenging to find, but hopefully I can find this one with my binoculars. I should be able to. But remember, early on in the presentation, I made a point of saying, hey, the Beehive cluster, when I'm in Houston, I'm going to be looking south in order to find the Beehive. So that kind of leads me to a bit of a story. I had an opportunity to visit New Zealand a couple of years ago, and I tried to get a night photo of Mount Cook, and to be honest with you, the effort wasn't all that great. But it did have something interesting in the picture when I got done with everything. And it was a star, it looked like a star cluster, but for the life of me, I couldn't figure out what the heck I was looking at. So I got home and, after resting up from the long trip, I got out Sky Safari and I said, well, let's go back in time and dial up the date, the time, the direction, all that good stuff that I was looking at when I captured this image, and see if I can't identify it. And I did. It turned out to be the Beehive cluster. But the weird thing was I was looking north, and that's why I couldn't figure this out. When I'm in Houston, I'm looking south, but here I was looking north. How can that be? Well, I was in the southern hemisphere. And as you may or may not know, when you're down in the southern hemisphere, everything's kind of turned upside down. So that's what ended up happening here. The reason I wanted to share that story was, number one, I like to get mileage out of my New Zealand trip, so there's that. But the second thing is that you can use planetarium apps on your phone to do some detective work. So I, kind of a little bit of an ad for next month's presentation. So that was the Beehive cluster story that I wanted to share. Next, we'll go to Leo the Lion, kind of wrap things up. And here we're going to start out with 2 of the 3 galaxies in the Leo triplet. This is M65 and M66, and this is in the Leo triplet. You can get to the Leo triplet by going about 12 degrees from Regulus, and I think that would be 12 degrees to the left. So you'd probably be going at, say, 9 o'clock from Regulus. But that's what you would be able to see. This is an image that the folks out at the George Observatory took last Saturday with their new telescope. And again, it's very, very cool looking image. So I asked him if I could use it. Here's the entire trio. So here's the M65 and M66, and then over here you see NGC 3628, which is an edge-on galaxy. So those all combined make up the Leo triplet. Okay. Okay, so that's kind of the end of our sky tour. Here is the summary of the objects that I've showed tonight. And again, what I've tried to do here is just provide a little bit of information about these objects, as well as some viewing options. So naked eye, small telescope, large telescope, EAA, these are suggestions that I would make for somebody that wanted to go out and find these objects. And these are suggestions. They're not hard and fast rules. So if you can find these objects with a pair of binoculars that I said you needed a small telescope for, well, more power to you. But this will just help you get started and give you some ideas on, well, what kind of equipment will I need if I want to go out there and find these objects. Some other upcoming events that are coming up in April, we have a couple of meteor showers that are on the horizon. The Lyrids and Eta Aquards are happening this month. These are major showers, so hopefully you'll have a chance to go out and witness those. And then there are a number of planetary events down here. The one that kind of caught my eye was Mercury and Neptune would be in conjunction during the middle of the month. And Venus will be bright here later on in the month. So again, some more celestial events that you can take advantage of during the month of April. Okay, so Novice Labs. Just wanted to say a few words about that. So for those of you that haven't heard of these, what is a Novice Lab? What a Novice Lab is, it's really an opportunity to go out into the field in small groups and tour the night sky and find featured objects like we did tonight, only to do it in real time and to do it for real. And so that is really what Novice Labs are all about. I only was able to put on one Novice Lab last year, and due to health reasons, that's about all I had in me. This year's a little bit different. I'm starting that back up. I really want to get out there and do it. I've had a group that I've tried to get out there for the last couple of weeks. Unfortunately, the weather has been an issue. So we're going to try again on April 19th and or the 26th to have our Novice Lab out at the dark side. So if you didn't have an opportunity to sign up earlier for this for the springtime lab, I'll send out another notice to the mailing group for HAS and with an invitation. And the next lab I'll try to do is in May, June, July timeframe. I'm gonna open the window for a couple of weeks, but if I get 50 people, I'll take all 50. What I'll do is I'll just bust up the groups into smaller groups, and we'll do multiple nights. So if you want to go, let me know. I'll get you on the list, and by hook or by crook, we'll get out there and make this happen. I still have a group of about 7 people that I'm working with now. With any luck, in the next couple of weeks, we'll make that happen. But I will be having more of these. I hope to have at least, 2 or 3 more before the end of the year. So I think it's a great tool. I think it's a great way to go out there and put this, these presentations into practice. And that's why I'm really excited about these. So more to come on that. Just a reminder for tomorrow night's meeting. At 7 o'clock, we'll have Keeping Dark Skies Dark in the Texas Big Bend region with Stephen Hummel. Stephen works out at the McDonald Observatory, and here I'm sure we'll have all kinds of great information about the activities that they're putting in place to keep the dark skies dark. And then we also have special interest group meetings in April. The Visual SIG special interest group will meet on the 9th at 7:30. Smart Telescope SIG the following Wednesday, April 16th at 7:30, and then the Astrophotography SIG will be on the 23rd at 7:30. Stephen Jones should be sending out an email with the details, so keep an eye out for that. And so with that, get out there and stargaze. Spring is a wonderful time of year, and with any luck, we'll get our Novice Labs in gear and have give people an opportunity to go out there and practice the types of things we talked about here tonight. So with that, I'm going to stop my share, and I am going to go to the chat. And I'm going to go down here to the first one. Does the southern hemisphere have a similar southern star that constellations rotate around? And this is from Michael Nelson. And funny you should ask. They do not have a single star. But I did go to a planetarium in Wellington, New Zealand, when I was down there. And they the coordinator, the leader of the planetarium presentation, said that they have a technique down there. What you do is you find the pointers and you get down to the Southern Cross, and there's a star called Acrux, which is on the end of the Southern Cross, and then you take your left hand over here to Acnar, which is another bright star in the Southern Hemisphere, and then you clap your hands, and where your hands meet, that's where the pole of the southern celestial pole is located. Not too scientific. There's plenty of room for error on that, but that's what they described to us in the meeting. So no, to answer your question, no single star, but they do have ways to find the celestial south pole. Did that answer your question, Michael?
Yes, thank you. That's interesting.
All right, so George Mendes asks, he says, for the lab at the dark site, do we need to own a telescope, and where do we sign up? Okay, great question. Oh, it's Jorge, excuse me. I'm sorry. So Jorge, no, you do not need to own a telescope. But if you have a pair of binoculars, or if you have a telescope, it's great if you can bring them out. So no, you don't. So where do we sign up? So again, what I will do is I will send out a general meeting or a general notice to all of HAS. And when you see that notice, then if you write back to me with the information requested, then you're on the list. And I'll confirm that I got your information, and then you will be on the list. And I won't let go of you until you tell me, uncle, and you need to get off the list for some reason. So that's how we sign up. There's no website or anything like that. It's just email communication between you and me. That makes sense? We good, Jorge? I'm going to take that as a yes. Jorge, you're on mute, so. Okay. All right. Let's see. Okay. This is from, is it Martial Luther? Am I saying that right?
Yes, thanks.
Okay, Martial. Please show the slide again with the equipment needed direct. Okay, I will do that. So let me share, and we'll look at that. And let me go. Let me do this with the old slide sorter. And there's always questions on this one, so I'm glad you asked, and I'll have a chance to, I kind of glossed over it a little bit, unfortunately. So here, oh, okay, there we go. Okay, here is the slide. If you want to come off mute, and did you have any specific questions about this?
Well, I was just curious to look at it, but it went by kind of quickly. So I just made a picture so I could contemplate
Okay,
further.
yeah,
But
I'm sorry, go ahead.
no, so I was just, what are the galaxies that you'd recommend more for beginners who might
Okay,
not have such large telescopes and such?
yes. Well, that's a great question. Um, I would try uh, Markarian's chain, which is really a series of galaxies. I think you'd have a fighting chance of picking those up, maybe even with some binoculars, because you're going to see smudges, what will look like smudges of light, and you'll see more than just one of them. So that would be a suggestion. Um, the spring the spring galaxies, I'd have to look at it a little bit closer and give you some recommendations there because they're small and they're distant, so the other one, the Leo triplet, might be another candidate. And again, it would be because you have three galaxies there that would be apparent if you were able to pick those up with a small telescope or binoculars. To really answer your question, the hands down galaxy that you want to, as a beginner, that I started out with was Andromeda, which is M31. Andromeda is a large galaxy. It's about the size of 5 full moons. At the dark site, you can actually, and I can actually make it out with the naked eye, and with a pair of binoculars, it is gorgeous. And that one's I've found that one in Kingwood outside my front yard. But that is an autumn galaxy, unfortunately. So with these, that's a good question. And again, I would start out with either Markarian's chain or the Leo triplet and give it a shot.
Thank you.
You're welcome. Were you able to get like a screenshot of this slide?
Yes, I
Okay,
did. Thanks.
real good. All right. There's that. Let's see what else we got here. And okay, I don't see any other questions on the chat. Does anybody have any questions that they'd like to ask? If so, you can just come off mute and ask your question. And if you do not, then I'm going to do my classic auctioneer thing. I'm going to say going once, going twice, and with that, the meeting is concluded. I thank you very much. If you do think of something later on, feel free to reach out to me and ask me a question via email. And with that, I wish you all a pleasant evening and wish us luck for our Novice Lab. Hopefully we'll get that under our belt and more to come there. So thank you very much, everybody.